Hello everyone, in this video we're going to cover in more details the center of numerical data. So we're going to look at measures of central tendency, or the center. Often these measures of central tendency include the expected value. We're also going to look at the mean of data, and the median of data. And again, in these situations we have one variable that's a numerical or quantitative variable. All right, so first of all, the mean value of a data set is the middle value and divides the data into two equal halves. So if we consider our data being this sort of lump of data, then our median here is the middle data that divides our data into two equal halves. So we would have like 50% of our data here and 50% of our data here. So this is a helpful picture to have in our mind whenever we get a list of data and want to find the median. All right, so there are two cases when we're finding the median of a list of data. So first case, we have an odd number of data values. We'll call data set A. So for data set A, how many data values do we have? 1, 2, 3, 4, 5. So the median is going to be the middle number here. So our median in this case would be 12. And that 12 separates our data into two equal chunks here. Something to keep in mind when you're finding that median like we just did, our data is going to be ordered. This method of finding the median doesn't work out if our data is not ordered. And typically our ordering is smallest to largest. And you can play around with determining, if our data was not ordered, say we had 18, 12, 8, 3, 15, then the middle value is not separating our data into two chunks. Well, it is, but not the chunks that we're looking for when we're finding the median. So I'm going to use M to represent the median. So M, median, in this case is equal to 12. So again, that's the case when we have an odd number of data values, but it could be just as likely that we have an even number of data values. So if we call this data set B, we have 1, 2, 3, 4, 5, 6 data values. To compute the median in this case, we separate the data into two chunks. But now we see that we don't have a data value that's actually in the middle separating those two chunks. So what we have to do is take an average of the two middle data values. So we have 12 and 15 are our two middle data values. So we add them together and then divide them by 2. So split them across two chunks here if you'd like. So 12 plus 15 would be 27 over 2, which for us is going to be 13.5. So in this situation, the median is equal to 13.5. Notice that in the second case, we don't actually have a data value that is 13.5, but the median is still this 13.5. So that was all computing the median. So the next measure of center that we have that we often use is called the mean. The mean or average, or the mean is the average of the data. Often we refer to that term as the mean, often the average. It's different words for the same thing. But we calculate this by adding up all of the values and dividing by the number of values in our data set. So to compute this value, we need to make a calculation. We're also going to look at how to do this using technology rather. But here is the calculation that we use to find that mean or average. And we're just going to take a moment to make sense of this calculation. So recall that we've already seen these notations. So the population mean, the notation we use is this mu here. Sample mean, the symbol we use is x bar. So recall that's pronounced x bar. And recall this little symbol here is called mu, like meow, but mu. All right, so what we're doing here is computing that X bar. So in the numerator, we have this sigma, or this Greek letter called sigma, that's often used in math to denote a summation or summing or adding up a bunch of terms. So I'll just write that down. So this sigma X means add up all the data values. Then this bar here, that's just a division or fraction bar. So then I'll say divide. What do you divide by? N. So N is notation for the number of total data values. So let's look at this using an example. So I'll use N here, or rather just emphasize N here is the sample size. Again, number of data values. So suppose we have our data values that I'll label with subscripts. So X sub 1, say, is 62. X sub 2 is 65. X sub 3 is 68. So in this case, our N is equal to 3. If we added up our X, or added up our data values, we'd have 62 plus 65 plus 68. Now, often in mathematics, we decorate this sigma with more terms. So we might say X sub I, where I goes from 1 to 3, but you don't have to worry too much about the specifics of this notation. Just know that this sigma is used to say, add up all the data values. So for us, when we add all these up, that would be 195. And again, just notation, this symbol here is called sigma. And we should just note in our brain that means to add up something. What? Well, in our case, all of the data values. So for us, our X bar would equal that 195 over 3. And that would be our average. So I'll make a little box over here to signify that that was our example. On the bottom of our page here, we have 2 different data sets that we're going to take the average of. So in this example, we're going to calculate the mean of the 3 data sets. Well, and it turns out we only have 2 here. So we'll calculate the mean of these 2 data sets, data set A and B. So we'll do the first one together, and then I'll let you do the second one on your own, and we'll compare answers. So in this case, X bar is going to be, we're going to, again, just sum up all of the X's, or all the values in our data set, and divide by the total number of numbers in our data set, or the sample size. So we have here that our N value, our sample size, is 1, 2, 3, 4, 5, 6, because we have 6 data values. Our sum of all of the X's is 3 plus 8 plus 12 plus 15 plus 18 plus 20. So you can get out your calculator to determine that. And I just paused the recording so you didn't have to watch me calculate that in my calculator. But when you add that all together, you should be getting 76. So now when we divide by 6, we'll divide both sides by 6. So divide everything by 6 all the way across. So our X bar is going to be 76 over 6, which again, if we pull out our calculator, becomes 12.66. We were just repeating 6, so we'll just round up. In this case, X bar, the mean or average, is 12.6667. Excellent work. So now please pause the video and work out the mean for the data set B. All right, I'm giving you time to pause the video. All right, so when we add up all those numbers, 3, 8, 12, 15, 18, and 205, divide by 6, you should be getting a mean of 43.5. So one thing that you might notice is that data set A and data set B differ only by their final term, 20 and 205. And we can see or to place the mean in the data set where it belongs in order. So 12.667 would be somewhere right here. That's where the X bar would be. In data set B, that mean would be somewhere in between the 18 and 205. So what do you notice or wonder about these two data sets and these two means? Well, for data set B, that mean is a lot larger than the mean for data set A, even though the data sets are very close, but just differ by this one term. So this just shows us that one outlier can have a big effect on the mean. I'm going to make a star because that's an important point. Outliers have a big effect on the mean. And there it is again for emphasis. Outliers or single data values, such as this 205, can have a big effect on the mean. So then you might be curious, well, how do outliers or single data values affect the median? So on this next page, we're going to look at exactly that. How do the mean and median and mode relate to the shape of the distribution? So we've already talked about mode, so we're just going to cross that out and just look at the mean and median and the shape of the distribution. So we saw three different shapes that come up most often in this class, and those again are symmetric, skewed left, and skewed right. So as you might expect in a symmetric graph, a symmetric histogram, or with symmetric data, the mean M is very close to the median, or the median M is very close to the mean or average X bar. So in this case, X bar is approximately equal to that median. But what happens in the skewed left or skewed right case? Well, when we're looking at data that's skewed left, that median, so the middle value, is still going to occur about where that peak is. And that's because the median doesn't care about outliers. It just counts data values. So it just looks at, okay, I'm going to just center in on the middle data value, and it's usually right above that peak. But then what about the average or the mean? Well, we saw that if we have outliers, so in this case, we have outliers down here, that's going to really draw that average down. So the average of a data that is skewed left will have a mean or average less than the median. And again, I encourage you to take some time, meditate on that idea, and think about that for yourself. So the median is going to be larger than the mean in this case. And then just like we saw the previous example, let me flip back. When we have a large outlier, meaning our data in this case would be skewed right, and we'd see that. So most of our data is here, and then we have that little blip of 205, so our data is skewed right. That single data value is going to pull that mean up, pull it higher. So if we're comparing our median and mean, then our average or our mean is going to be larger than that median. So in this case, if we compare our median and mean, that median is going to be less than our mean. So when you're considering about how the mean and the median interact, I encourage you not just to memorize this section of the page. I encourage you to think through it. Think about, okay, we do have some outliers that are small. So that's going to push that whole average. It's going to pull that average down, making that average, thinking about in this example, less than the median or middle number. So let's look at an example where we can compare the median and mean of some actual data. So in this example, we have a dot plot of box office earnings from Hollywood movies. So first of all, is this data skewed left, skewed right, or symmetric? Well, we see that the tail or the outliers are here on the right. So this data is skewed right. So just looking at the dot plot itself, we can estimate the median and mean. So the median will be the middle data value. So we could count points. We could say point here, point here, point here, point here. In this way, we're going to be able to isolate 1, 2, 3, 1, 2, 3, that middle data value. So I encourage you to go through this process for yourself. And you can count like groups of 4. So I'm going to cross off 4 there, cross off 4 there, cross off 2, cross off 2, cross off 2, cross off 2. In this way, we're going to narrow in on that center data value. As we keep doing this, that chunk, this chunk, that chunk, this chunk, we're going to focus in on that median value. So we see it'll land somewhere here. So here's where the median, or M, will occur. So it looks like somewhere between 50 and 100. So we'll say about 70. We're going to see an example of how to actually compute this. But then what we'll observe is that because of these larger values, that mean is actually going to be skewed right. So these 2 or these 3 outliers here, those are going to be some blockbusters, right? Movies that really generated a lot of income. So these are outliers in our data. So something to note here, and this is some new language, the median we say is resistant to outliers, while the mean is not. So the median, again, is resistant to outliers. That means it resists, it does not move if you throw in some larger or smaller values or outliers. The mean is not, though. So the mean will change. So mean will change if you throw in outliers with outliers. So at this point, what I want to do is transition into a Google Doc to show you how you can actually compute the mean and median for this data set. You're going to be using Google Docs and other spreadsheets a lot in this class and throughout your life. So it's great to see some examples right away. All right, so here is a Google Doc containing some movies and the earnings of these movies. So what I'll do in a separate cell is I'm going to write out median just to keep things organized. And then what I'm going to do in the cell next to it is actually compute that median. So I'm going to say equals. By entering an equals, I'm telling Google Sheets that I'm going to insert a formula or a function. I'm going to compute the median. So I'm just going to start writing median, and here it comes up for us. So notice that I have a parenthesis here right after the median. That means I need to enter the values that I want to take a median of. So to do that, I'm going to go over here into my list. I'm going to click, hold the click down, and then drag my mouse down to select all of the data that I want to take the median of. So you'll see, and now I just let go once it's all selected. You'll see that I have the cells B2 all the way to B135 selected. Then I end parenthesis and return. And what I get is that median. So now I'm going to do it again for the mean. In Google Docs, the term that they use to compute the mean is average. So we're going to compute the average. I start writing average, and there it has it for me. Now, rather than selecting, I can also just type in the data. So I want B2 and colon all the way up to B135. And I can just scroll down and check that indeed those were the cells that I wanted. So then I end parenthesis, press return, and I see that the average is 150. So we can see here also that our average is quite a bit larger than our median. So we did a pretty good job when we estimated that on our dot plot. Awesome. So now let's head back over to our notes to finish off this page. All right, so now just heading back here to a final wrap up for the fictional exam data. How do the mean and median compare? So we saw in this data, and this was actually not exam, this was coming from a different example. So in the fictional movie data, how do the mean and median compare? I want you to pause the video and write a sentence for yourself here. So you should come up with something like, the mean is skewed to the right. So note that that means that often that mean is not as accurate. Or rather, it's not accurate in telling us kind of the true representation of the center of the data. So often, when we have outliers, the median is more accurate or true to giving us a picture of where the center of the data lands. So now just to summarize, there are two different sets of measurements for center and spread. What are they? They are mean and median. For skewed distributions, we want to use the median as the center data value that we collect or compute. But for symmetric distributions, often as we saw, the mean and median are very similar, so we usually use the mean. And now in future videos, we're going to look at spread of data, and we'll see the two types of data that we look at in terms of spread are the interquartile range and the standard deviation. All right, thanks for watching. Please rewatch any parts of this video on your own, and I'll see you on the next one.